Example number two, we're now looking at a different situation. I have a 500-gram block, so not a very large block, being pulled at a constant velocity, this is very important, by a 3 Newton force. And I want to know the coefficient of friction. Now, when I go to look at this, the first thing I always do is draw my free body diagram. I know I'm going to have a normal force because it's sitting on a surface, and I'm going to have the gravity force pulling down, right? Those two are definitely there. I also have an applied force because it says it's being pulled. But this is the important thing, is constant velocity. Constant velocity means I must have balanced forces. It means that my applied force and the opposing friction force are going to be equal. I don't know if I drew them totally equal, but they're supposed to be the same length, the friction and the applied force. This is really important because if I didn't get this, if I didn't notice those words constant velocity and I didn't understand what they meant, I wouldn't realize that I know not only the applied force, but I know the friction force too. It's a constant velocity by a 3 Newton force. That means the applied force is 3 Newtons. It also, though, means because it's a constant velocity, the friction force is 3 Newtons. And if I didn't catch that, I'm in trouble. I'm going to spend a lot of time staring at this question, wondering how the heck I can do it. Now I just need to think about the equation for friction. The equation for friction is equal to the coefficient of friction times the normal force, which means I need the normal force before I can solve for my coefficient. But remember, we're on a nice flat surface, which means the normal force, is equal to gravity. So I can find that very easily. Now, one thing that's important is we talked about this in earlier questions. I have grams, and should it be grams? No, it needs to be kilograms. I have to change my units. 600 grams needs to go to kilograms. So 3 decimal places or divide by 1,000, whichever makes sense in your head. But I need to make my conversion of my mass. So I need to use that. Otherwise, I'm talking about a lot of gravity on a small object, which is not really true. So I can calculate that so I can find that this is equal to, I'll write it down, that Fn equals Fg, and they both equal 0.6 times 9.8. So a force of 5.88 newtons. I'm not going to worry about rounding yet, right? Because we're not done yet. This is not my final answer. My last thing I'm going to do is find my coefficient. My goal in this entire question is to find my coefficient. So I know my force of friction is 3 newtons because it's the same as the applied force. I'm trying to find my coefficient. I know my normal force is 5.88. So all I have to do is divide. Now you'll notice I get a decimal, but I should, because remember, the coefficient of friction is really just telling me the percentage of the normal force, which is being converted to friction due to the slipperiness or the smoothness of the surfaces. And it tends to be a decimal because it tends to be less than 100% because it is a percent in decimal form. This is where I'm going to think about sig figs. I used my 9.8. I had 3.0. I'm going down to 2 digits, so 5.1. Whoops, and that's not the force of friction. Sorry, that is my coefficient. See, even teachers make mistakes. Easy thing to fix. I was solving for my coefficient. Now you'll notice there's no units on this. There are no units on the coefficient, right? Coefficient does not have units, and that's because it is a percentage in decimal form. No units on that. Strange thing, I know. I'm going to tell you to use units every day in this course except for this one on this particular thing. So now I can write my therefore sentence. I'm ready to go. No problems.